Welcome. This is Math 159 for Gould, Chapter 3, Section 4. We're going to be comparing measures of center. So you might recall that we talked about summaries for symmetric distributions, and we talked about summaries for skewed distributions. And if you have a symmetric distribution, you're interested in using the mean as the measure of center and the standard deviation as the measure of spread. If you have a skewed distribution, you're interested in using the median as the measure of center and the IQR as the measure of spread. So really, you need to look at a graph first so that you can see the shape. Is it symmetric or is it skewed? And then you can choose your measure of center. But we're going to look to see what happens with a variety of things. So let's do an example here. Let me bring up StatCrunch. Okay, come on, StatCrunch. Boom. Okay, there we go. So we're going to look at, this is a data set that's about income. It's actually from a census. So let's just quickly look at the variables here. So looking at row 1, this is this subject. The information is from the year 2000. They're from Florida. They're 33 years old. They're male. They're white. They were married, and there's this total personal income. So what we're going to do is we're going to take a graph and make a histogram of total personal income. And you can see right away that this is definitely a skewed distribution. The mode is here at incomes between $0 and $250,000, and that the right tail is very long because there's some people who make up to like 3.5 million or so, like way over here. Okay, so you can see that income is a very skewed distribution. Most people make less than $250,000. There's some people who make way more than that, which skews it off to the right. So I'm going to click Options. I'm going to go to Edit, and I want to have it put the markers for us, the mean and the median, which were right here. Okay, and then I'm going to say Recompute so we can see them. So this is saying that the mean amount, and you would not use this one, the mean amount for income is $28,883, and that the median is $21,000. So what does that mean? What does that mean? What is the context of this is what I should say. Half of the people make less than $21,000, and half of the people make more than $21,000. So in this case, if you wanted to capture or summarize this distribution because it's skewed, you would look at the median. The typical income is about $21,000, and then you would want to look at IQR to talk about the spread. Okay, let's look at another one. Let's see, there's another variable here called log income. You can see that this one is actually quite a bit more symmetric compared to total personal income. You'd probably be more interested in using the mean here, so let's put the mean and median markers. So yeah, it's much, in this case I would probably use the mean. In this case, the one for total personal income, I would definitely use the median. Okay, so let's talk about the effects of outliers on your data. So what I'm going to do is I'm going to make up some data here. And our variable is going to be, let's do number of times that you go to the bathroom each day. So bathroom breaks. Okay, so let's say you ask a bunch of people and someone's like, I go once a day, once a day, once a day. Someone says twice, 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 twice. 3 times, 3 times, 3 times, 3 times, and then someone says 4. So let's copy all of those. We're going to make a copy of it over here, so I'm going to make 2 copies of this data. And I'm going to call it bathroom outlier. Okay, so you can see that the data is all the same. So let's look at the graph of bathroom, number of bathroom breaks. Okay, I'm gonna need, actually let's look at the, not histogram, we want the dot plot. Where are you, dot plot? Dot plot. So bathroom. Okay, I guess I'll add some more data to this. Let's see how that looks. So graph, dot plot, bathroom breaks. Okay, there we go. And we'll get rid of this one and that one. Okay, cool. So looking at this, you can see that it looks pretty symmetric. It's at around 1 and 5 on the edges. There's not that many of them. At 2 and 4, there's more. In the middle, there at 3 is the majority of people. Okay, so let me copy all of this over. We'll make a copy. And then make it go like this. Okay. And we're going to have it plot for us the mean and the median. Okay, so for this, because it's symmetric, the mean is 3 right here in the middle, and the median is also 3. You can see both of them are right there. The median is 3, and the mean is 3.04. So typically, how many times do people go to the bathroom? 3. The mean and the median are both the same. Now, in this other variable over here, which I call bathroom out with outliers, we're going to change this 5 and call it a 10. So the only difference between these two sets, they're all the same all the way up to line 23. All of those are all the same except for this last one right here with, instead of someone going to the bathroom 5 times, there's someone who goes to the bathroom 10 times. Like they like to drink a bunch of coffee and tea or something. So what we're going to do is we're going to make a plot of the bathroom outlier variable. Remember that one only has one changed number, and we're going to put mean and median. So all of the data is the same. Like all of this stuff, the one above, is the same as the one below, except for this one outlier over here. And you can see what ends up happening is that it changes the data. Before over here on the top one, the median was 3 and the mean was 3.04, but on the bottom one with the outlier, the median is still 3, but the mean has become 3.25. And I'm going to change this 10 a little. I'm going to say instead of going to the bathroom 10 times, they go to the bathroom 20 times, and we're going to have it recompute it. So now you can see, here's all these people over here who go to the bathroom 1 to 5 times, and then here's this one person over here who goes to the bathroom 20 times. Notice that the median is still 3, this red line right here, but the mean has become 3.66. So what I'm showing you is that the median, if you throw in an outlier, the median doesn't react to it. The median is still 3, but the mean has increased to 3.66. So what ends up happening, the median, that's why we choose the median for these skewed distributions. The skewed distributions usually have outliers like this 20 over here. The median doesn't really change. It stayed at 3. It started off as 3 up here above, and it stays as 3 here below. So the median, it's not sensitive to outliers. It didn't change much, but the mean did. So if you have a outlier, it is a good idea to use the median because it is more representative. Okay. Let me go back to OneNote. So we talked about how do you choose which one do you use? Well, you look at the graph. If you have outliers, you need to use, median because the mean changes greatly in the presence of outliers. Okay, here's another question. Up till now, we have only looked at data with one mode, right? Remember the mode is the high point, and then using that one mode, you determine if it's skewed or symmetric. What do we do if we are dealing with a multi-modal distribution? Okay, so I'm going to go to StratCrunch and we're going to look at an example of this. What do we do if we have a multimodal distribution? Ah, there we go. I was like, where did my StatCrunch go? Okay, so we're going to go to these marathon times. Okay, so what this has is it's times for marathons. It gives you the name of the athlete, what country they're from, how long they completed the marathon in, I think it's minutes, their gender, and then the event. So if you scroll down, you can see there's a lot of males and females at the Olympics, and then there's a lot of males and females who are amateurs. So this data has Olympic athletes as well as people who just run marathons for fun, basically. Okay, so we're going to go graph, and we're going to go to the histogram, and we're going to look at their times. Okay, so looking at this, it appears to be multimodal because there's a hump right here, and there's a hump right here that's actually pretty close to the one on the left. And the reason you actually have these two humps or modes is because there's two sort of separate groups here. There's professional athletes and there's amateur athletes. So StatCrunch actually gives you a way to separate them out. And so whenever you see a multimodal distribution, or in this case it's bimodal, there's two different modes, right, with two different high points separated by this gap right here in the middle, it's usually because you have two different groups that you should analyze separately. So how do we analyze them separately? Well, let's go back to the histogram. You use this group by option. So I just highlighted it right here, group by. And we're going to group it by, let's do first gender. Click compute. So here is all of the female athletes, and here are all of the male athletes. But it's still bimodal. So what we're going to do is we're going to break it down again, or another way. Let's go group by event. So these are the amateur athletes, and I can click over here with the little right arrow, and here are the Olympic athletes. And you can actually see now that this is now a unimodal distribution, right? Here's the mode right here. It's a little skewed to the right, but at least we have a unimodal distribution. Same thing if we go look at the Olympic athletes. It's a unimodal distribution. It's skewed right a little, but what do we have? It's unimodal at least. Okay, so you can see that there's a difference between the times or the distributions of people who ran a marathon at the Olympics and people who ran the marathon as amateurs. Which should make sense, right? The Olympic athletes should probably be a lot faster. So what I'm going to do is I'm going to go options edit, and we're going to have it put a median. So looking at the amateur athletes, the median time to complete a marathon was 249 minutes. Sorry, 249. And sound a little weird there. So anyways, amateur athletes typically took 249 minutes. Olympic athletes typically took 148 minutes. They're a lot faster, right? We're using the median because, there's an outlier over here. So you can see that we were able to take our original multimodal distribution. Let's make it again, graph, histogram, we'll go time. We originally had this multimodal distribution with these two high points right here. How did we get unimodal distributions? We had the graph break it into two groups, or group by which event they ran at. And the events were either amateur events or the event was Olympic events, right? And then we turned it into a unimodal distribution. So often you have to play around with this a little, and you use it to compare the two groups. So what can I say? Well, the typical time for amateur marathons was 249 minutes. That makes sense because this is still a right skewed distribution, so we should use median. And the typical time for marathons at an Olympic event was 148 minutes. It makes sense that we use the median because this is right skewed and we have an outlier over here. Okay, so thank you for watching the video, and this is the end of the video.